Welcome back to SanfordFlipMath. This is AP Calculus. We are working through the derivatives chapter, and specifically from the Calculus Finney, Demana, Kennedy book. The same stuff from pretty much any calc book. We are working in section 3.5, which is the derivative rules section. So just so you're aware, we're going to be looking for ways to find y prime for these functions. So sine, cosine, tangent, cosecant, secant, cotangent, so the trig functions. I'm going to be kind of cruising today through where you can, kind of find some of these rules and like how to derive them, etc. I'm not going to go through a full-blown proof of the derivative of sine of x. You can see your book for that, or many sources for that, and it deals with the sum and difference formula for angles for sine and also for cosine, excuse me. But I am going to look at graphical evidence. So we're going to look at the graph for sine of x and then compare it to the graph of the derivative of sine of x. So you'll notice that we have this says the derivative with respect to x of y1, and it's going to do that at every x value. Okay, so I'm just going to hit graph, and we'll see what it looks like. And I'm not sure what kind of screen this is on, so I'm going to stop it. I pushed on to stop it, and I'm going to zoom trig, so zoom 7. All right, well, this might be the same screen. Okay, and there we go. It takes a little longer for the derivative to calculate at all of those points, so that's why it's going slower. And I guess the thing to notice here is that we have the sine graph, the original sine graph. That's this guy. And then as you think about the slopes, it's pretty steep here. The slope happens to be 1. Not so steep here, so the slope happens to be 0. And so as we go through this, the slope of the sine curve looks like a graph that should be pretty identifiable. And it happens to be cosine. Just to confirm that, let's pop down to y equals, or y3, and we'll put in a cosine x. And I'm going to have this kind of trace a little circly thing while it's graphing the third one. All right, there we go. Let's hit graph. And if you notice, so this is really y3 tracing over y2, it happens to be. So in other words, that third function is the same, or now, this isn't proof or anything, but it is decent graphical evidence. And we'll just take a quick look at the table. Okay, and let me get rid of this crazy graph. There's probably a quicker way to do this. I'm sure there is. I know there is. Sorry. So I just want to kind of compare y2 and y3. And the numbers look really, from what I can see, they look identical. Okay, so it looks to me like the derivative of sine is cosine. And it is. Again, you can go ahead and take a peek at the evidence in the book in section 3.5, and you can confirm that for yourself. What I'm going to do next is do the same kind of thing for cosine. Let's take a peek at what the cosine graph looks like, and then it's going to graph its derivative. Okay, so here's the cosine graph, very familiar. And here is the derivative of cosine. So the question is, okay, so derivative of sine is cosine. Is the derivative of cosine sine? Well, not exactly. I mean, sine would have looked like this. So it's not sine, but it is something pretty similar to sine. It's actually negative sine. It's the upside down version of sine. It's sine with a transformation done to it. Okay, so the derivative of cosine is negative sine. Okay, well, if you recall, everything else, all sines and cosines can be written in terms of, I'm sorry, started saying it backwards. All other trig functions can be written in terms of sine and cosine. So tangent, cosecant, secant, and cotangent, for instance, can all be written in terms of sines and cosines. So what we're going to do is we're going to pop over to another screen, and we're going to look at y equals tangent of x. And just a reminder that the derivative of sine x is cosine. The derivative of cosine is negative, or the opposite of sine. Okay, so we need to remember that, because what we're going to do, tangent itself is sine over cosine, so we're going to do the derivative of sine over cosine with respect to x. So this is a quotient, so we're going to follow the quotient rule. So buckle up, here we go. The denominator times the derivative of the numerator, derivative of sine is cosine, okay, minus the numerator times the derivative of the denominator. Well, the derivative of cosine is cosine squared. I'm sorry, the derivative of cosine is negative sine. Sorry, I was thinking ahead as to where I was going in the problem. And on the bottom, this is just going to be cosine squared. All right, so let's clean this up a little bit. I mean, that's not very fun to remember or to use, because what we're doing is developing a rule for derivative of tangent. Well, minus a negative, so this is really plus sine squared. Cosine squared plus sine squared is 1. Well, 1 over cosine is secant. So 1 over cosine squared is secant squared. So we just found a rule for the derivative of tangent. Okay, so derivative of tangent is secant squared. Okay, most of our time here today on this, well, in this recording is going to be spent deriving these rules. Okay, so bear with me. Cosecant well, that's 1 over sine. Now again, remember that sine of x, the derivative of sine of x, is cosine of x. Okay, so we need to remember that. Well, the only way I know to do this at this point in this in our adventure is to do the quotient rule again. So I know this is quite exciting stuff. So y prime is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Well, this is incredibly exciting. This whole thing obviously is 0, so I have a negative cosine x over sine x. I'm sorry, sine squared x. Well, that's not terribly exciting. I'm going to rewrite this, and you may decide that you don't like the form that I'm going to write it in, but I'm still going to do it. And I'm going to write the negative out in front. I'm going to write 1 over sine times cosine over sine. And so that can be written then as cosecant, well, with a negative, and cotangent. Okay, so the derivative of cosecant is negative cosecant cotangent. Now, I'm thinking the reason that they picked this form, okay, let me just write it all in one spot, is because of that cosecant cosecant idea. Derivative of cosecant is negative cosecant cotangent. So it kind of flows, okay? Okay, so negative cosecant cotangent. Let me pop back to where I'm listing these. Okay, so y prime here, negative cosecant cotangent. Well, I'm going to speed this along a little bit. And again, feel free to consult the book, and some of this might come up in homework, etc. But y prime for secant is secant tangent, and y prime for cotangent is negative cosecant squared x. All right, so these all need to be in your list of derivatives. You know, they're already on the list that I passed out, and then in class, but in terms of the things that you remember. Okay. All right. So what I want to do is kind of pop over to the PowerPoint, and this PowerPoint is located on my Google website. Hang on just one second. I know it won't seem like long for you. All right. Well, welcome back. Going to pop into a PowerPoint presentation for just a minute. And I don't think I've really done this for you yet, so I'm just going to kind of recap some rules for derivative. So that's the power rule. You've seen that before. Product rule and quotient rule. Okay, and so these are the trig rules that we've just been looking at. Okay, and the only reason I'm here is I want you to see the patterns here. Okay, so sine, derivative of sine is cosine. Derivative of cosine is sine. What I'd like you to kind of do is kind of focus on the main one without the co first. Okay, and so sine, cosine. Tangent, secant squared. Secant, secant tangent. And the reason is if you focus in on those three, the co-versions of them are the co's. The co-function versions of these are the co-function versions of their derivatives. For instance, I know that derivative of sine is cosine. Derivative of cosine is sine. Okay, so there's this, see how they switch to their cofunctions? Sorry, that's flashing. I don't know what's going on. I don't really, it's annoying. If I know that the derivative of tangent is secant, well, cotangent is cosecant. And similarly, derivative of secant is secant tangent. Derivative of cosecant is cosecant cotangent. Okay. Now, the other thing that is probably worth noting here, and I know this is starting to get a little messy, so in a minute I'll stop and I'll clean this off and we'll recap. But anything that has a derivative that starts with a c, its derivative, the derivative of anything that starts with a c starts with a negative. Okay? And so now this isn't why these are their derivatives. This is just a way to remember them. Okay? And that's going to be the tricky part, is remembering. Because obviously there are 6 rules here, and you know, you already have 3 rules to remember, which I don't think are too bad, and you've been using them for a few days. But when you start adding on these 6, well, if you can think of these 6 as 3 with some alternate versions, then that's going to make things a little bit easier. Okay, so let me do something real quick here. Okay, that's a lot of fun. No, I don't. That's actually the entire point. Thank you. Awesome. Now let me go back to the show version of this. Okay, let me just pull these in. And okay, so this is drawing attention to the negative that goes with the functions that start with a c. Okay, so that's my entire point in that last little bit with all the ink all over the place. Okay, so if you can focus on sine, tangent, and secant, the ones that don't start with a c, the ones that do start with a c will come along for the ride. Okay, no, I don't. Thank you for asking. Okay, again, that PowerPoint, and there are, you know, rules for derivatives that go all the way through the entire list in that PowerPoint. So if you want to see that PowerPoint, it's up on on my website. Okay, so this is a screenshot of the last page of the PowerPoint. So at this point, we have discussed all of these. Okay, so this is section 3, and this is 3.3. These are also section 3.3. Okay, so that whole first box is section 3.3. This is section 3.5. Now we will be doing, before we take a test, we will be doing section 3.6 also. Don't freak out yet. There's plenty of time for freaking out later. All right, let me just pop in and see where we're at. 15 minutes. All right, cool. We're going to go ahead and do a couple of examples just to see what's going on. And I'm going to steal these right out of the Finney, Demana, Waits, Kennedy book. Thank you. Just need something quick. Okay. All right, so we're going to do some derivatives with the trig rules. So how about 2 sine x minus tangent x? Okay, so it's pretty straightforward. All we're going to do is follow the rules. Okay, well, remember that if you have a constant multiplying, a number multiplying, you can just bring that along. Okay. All right, so remember again, sorry, I'm sure I'm repeating myself, but if you have a constant multiplier, a numbered multiplying out front, you can just kind of bring that along. It multiplies the derivative also. And then we can just kind of go term by term here. So, well, and 2 is part of that term, but derivative of sine, from that little list we just saw, derivative of sine is cosine. Okay. So that's cosine. And derivative of tangent, went the wrong way, sorry, is secant squared. Okay, so there it is, tangent secant squared. And yep, that's it, y prime. Okay, let's do another. Okay, let's do x secant x. Okay, so if y is x secant of x, y prime is, now I can't just bring the x along on this bad boy because this guy right here is not just a constant. So this is a product, this is u, this is v. We're going to follow the product rule. So again, I reverse the product rule because I like it to look more like the quotient rule, and maybe that's the exact reason why they didn't do that in the book. So the second thing, secant x, times the derivative of the first factor. So derivative of x is 1. Okay, this is plus because this is product rule. If this was quotient, we'd be doing minus. I'm sorry. So derivative of the second times, I'm sorry, the second times derivative of the first plus the first times the derivative of the second. So derivative of secant is secant tangent. Again, that comes from the list. And again, you're just going to have to know that list. Well, there's really not much else to do with this. I mean, you can leave this secant x plus x secant x tangent x. That's fine. It's beautiful. If you have this crazy sense of order and you feel the need to factor out the secant, you can. And really, the only reason I would do this is if you were looking at a multiple choice question and your choice didn't appear to be there. Okay, so that would be my only reason for doing something like that. All right, let's do one more that's less pretty. Okay, sorry, I don't want to get too far down the page here. Let's do y equals cotangent x over 1 plus cotangent. Okay, again, these are coming straight out of your book. Okay, so y prime. Okay, so what we're going to do here is the quotient rule, because shockingly enough, I have a quotient. Okay, so this is going to be u. This is going to be v. Okay, so this is the denominator times the derivative of the numerator. Now, the derivative of cotangent is kind of like the derivative of tangent. Derivative of tangent secant squared, so this is going to be cosecant squared. But it's got to have a negative in front of it because anything that starts with a co its derivative has a negative. All right, so quick recap so far. Denominator times derivative of the numerator. Okay, so this is u prime. This was v. Okay. Again, that's all going to be over. All right, okay. Denominator times derivative of the numerator minus the numerator. Okay, so this is u. Cotangent of x times the derivative of the denominator. Well, derivative of 1 is 0, and then the derivative of cotangent we've already discussed is negative cosecant squared, all over the denominator squared. Okay, so first note, in terms of derivative, I can be done. Okay, that was v prime, and this is v squared. I have done the derivative. Now, I will say that we should probably clean this up a little bit, but again, if you're on a test or something, free response for the AP exam, you can be done. If all they're asking you for is the derivative, you can be done. I'm going to clean it up a little bit. I'm probably not going to clean it up a lot. My biggest concern is that I think some stuff's going to cancel out on the top. So like if you were checking the answer in the back, it wouldn't look like this. So I'm going to go ahead and distribute this negative cosecant squared. So negative cosecant squared minus, I'm going to write this in this order just because I'm looking ahead. Now, this is minus, and this is all multiplication, so we're not distributing here. I'm just making sure that I notice there's a negative times a negative. So I'm going to make that plus. This is cotangent cosecant squared x. And all of this is still over my denominator squared, which I am not going to multiply out. I don't see any reason to do that. Okay, I'll say that now. And then notice that some of this stuff goes away, which is kind of cool. So on the top, negative cosecant squared. On the bottom, 1 plus cotangent squared. Issues here. Try again. 1 plus cotangent x, then the squared. Okay? That's kind of pretty. I like that. Okay, so that's my favorite. Okay, and just because it is my favorite, I'm going to circle it with a crayon. Okay. Well, that's it. You have a number of rules to learn. Add on to your list. Again, focus on the 3 that are not cos, and then just remember that for the co-functions, all of the cos flip, and they become negative. Okay. All right. Start studying that sheet. Don't wait until the day before. You need to start drilling yourself. Make flashcards. Put the function on one side. Put the derivative on the other side. Start learning them frontwards and backwards, because at some point you need to be able to recognize them backwards also. Okay, not for this test, but it will come. All right, thanks for stopping. Thanks for watching video.